Hi, everyone. Um, Thank you for the introduction. So just to give an overview of the motivation behind this talk is that generating interactive narrative games requires a lot of technical skills if you're doing in Unity or any of the other engines. Our contribution is trying to see if you can actually use just simple natural language instructions to actually generate a playable interactive narrative game using AI and large language models. So there are some key questions that we're trying to address. One is can you actually simplify this generation using a natural language instruction? Like I said, is the whatever is generated, how well does it align with what was provided as in designer instructions, and also to see if I can generate something where the player has a little bit of agency in terms of exploring the space while we still kind of guide them towards to the through the narrative. And finally, like we're going to evaluate this using both automated and human. There is a lot of work that's been done in this space, and it's going to be difficult for me to talk through all of that in the interest of time. I'm just going to talk about one work that we did and presented last year in AIIDE, because this is going to be a component in our final framework. So this is where the author provides who they want to talk to, where they want to have this conversation, and maybe a topic of conversation. And the system basically uses large language models to build out the dialogues, maybe emotes and gestures for all the characters. And if there is multiple variations of how the conversations would go, it builds out branching. At the end of the whole thing, there's a Python data structure that gets translated into ink. Ink is like a text based script language where you can actually write text based games, if you will. It allows for jumping and like branching and other things, and we basically have extended ink with some of the Unity functions. So this ink script can actually become a playable engine, picks it up, brings together all the other visual assets that's already be pre-built, like for characters and locations, and makes it a playable game. So this is what I demonstrated last year. So what we have done is kind of moved it a little further. So in scene craft, which is the gray box that you see in the middle, you are actually only have the like the single scene. So what we have done is basically the author gives you a narrative arc, and then it gets translated into beats or scenes, and then it also we also add some constraints on how the narrative should go, and like place characters in the right place and all those different things, and then flesh it out with scene craft, and again it becomes a playable game. So I'm just going to go through some of the different components that I mentioned. The narrative beat generator is essentially takes the intro or like the arc provided by this thing and creates them into single scenes, and the scene would have like the location, the characters, what happens in that scene, and also some kind of indication as to how the next beat or next scene would be. And the event dependency resolver is more like a kind of constraints the narrative. It creates first a graph based on all the beats, and it creates a partial order in which if the player kind of goes out of this list or the structure, they get hints on how to who they should be talking to. So this is basically a way to kind of constrain or scaffold the narrative structure. And finally, the character game asset locator, since we are actually playing a physical three-dimensional world, for it to be believable, the everything needs to move around, kind of match what the narrative beats says. So for example, if a player talks to Andrea at the beach, then talks to a scientist about like the fishes that are dying, and if they go back to the diner and have to talk to Andrea needs to kind of come to the diner on their own in the game, even though the player is just moving around on their with their however they want to go. The rest of the characters need to come into play so that it's actually become a coherent narrative. So to summarize, the designer provides a narrative arc. We generate a set of beats. We create a graph that kind of talks about how the beats are organized. We provide the scaffolding to make sure that the narrative progresses in the right direction. We generate the script, and then it becomes a playable realization. So I'm going to do a demo. This is a example of input from an author. So it's just like 50 to 60 words maybe. It talks about a player visiting his uncle who has a rice fish farm. He's having some trouble, and they try to solve the issue. So what you're going to see is a game that is generated. Everything in this game is automatically generated. There was nothing manually specified other than the input that you saw. There is branching happening. The player has like expressions based on what they're talking about. And you can see that it starts off with the player like talking to his uncle and trying to understand what's happening. And you see the characters that were picked from a whole collection of library of characters that we have also kind of matches the description of what the player or the story narrative expects from this character. So you get an older gentleman for the uncle, and some of the other players kind of look different as well. And then the player can move around in the space and talk to different characters. But if they go out of order, let's say in this case, where they talk to this character out of Carmen out of order, they are asked to like kind of go and gives them some direction as to who they should talk to with text. So but of course, once you go and do the necessary beats or you've met the sufficient conditions, you can go back and talk to this character, and they kind of give you something else based on this is like the middle of the story, so they kind of talk about details about like the fish dying and rice fish farming and other things. And you'll also notice that like the uncle is on their side in this conversation because they also have a dialogue that comes up. But for this to happen, the uncle had to come from the river to here, and all that is managed by the other system that I mentioned to kind of make sure all the players and characters are in the right place. Now, after this, they finally go and talk to somebody who can actually solve the problem for them. So you actually have like a narrative arc in the sense that you had like a introduction to the problems, a description of what's happening, and maybe somebody who can provide some kind of solution to the problem. So it just follows that arc, and then it comes to an end. So after talking to this person who kind of has a solution, of course, everything that all the text you're seeing is all like generated. So there is very little control at this point on what actually happens in this text. But it's all driven through the main narrative arc. And at the end, after all this is done, there is a farmer who basically thanks them, and the narrative ends. So this is like a very simple 4 or 5 beat narrative that was generated. So one of the things we noticed as we generated longer and longer narratives, that the graph became very complicated, and it's hard to kind of maintain all the state. So we added another component, which is the experience manager component, that was also based on LLMs, which takes the game history and then changes the dialogue in response to what's happened till now. So in this case, to kind of do this testing, we didn't want to do the full generation because then it becomes very hard to test. We created a sample scenario with like a stolen artifact in an island where we did do the generation, but then we manually curated the dialogues and things like that, so that it's kind of constrained into very few characters. So in this case, this is another generation, but here we are actually talking about dynamic generation of the content. So the initial setup is all like fixed, where they talk about like what's happening and the stolen artifact fact and all the different suspects that are involved. And then the player goes and talks to Elise, who's like a forensic scientist or something, who basically gives them the clues. So it's kind of contrived because she knows all the clues and she talks about everything, and you just ask her questions and she kind of tells you everything about what happened for that specific scenario. But then after you kind of learn about a few clues, then you make a guess as to who the perpetrator is. And if you make a wrong guess, then she gives you a hint as to what else you should be looking into. And that hint that you will see that comes up is basically dynamically generated based on what the player has already seen and what is relevant to actually solving the system, solving the mystery. So at the end, after talking to Elise and figuring out what's happening, you go talk to Robert, who's a chief investigator, and he summarizes the whole mystery and what the investigation and everything. And this content again is completely dynamically generated, and it's based on the player history, on what clues they already know and what they do not know, and it kind of gives them like a sense of the overall picture of what's happening. So this is a setup that we use for testing dynamic generation. So I'm going to go further in the interest of time to talk about the results of how we evaluated these systems. First, for the narrative generation aspect, where you actually have an input arc and then you generate the story. We took 10 input arcs and generated 5 different versions of each for each arc, so about 50 generations. And for in between those, we compared 2 generated content like stories from the same input versus generated content from different inputs. Of course, obviously, the ones that from different input are like more dissimilar compared to, or the ones running from the same input are more similar, which is the blue one. But you do see that like there is a significant overlap. So there is cases where like even though it's the same input arc, you actually have a lot of variety because there are significantly different. You see the blue coming all the way to the left in terms of blue gel scores. And the next thing we checked to see was the alignment between the input arc and the generated content. Of course, things that were generated from the input arc kind of match with the input arc. As expected, the cosine distance was small compared to the ones generated from different input. But of course, there's only so much you can do with automated generation. All it's doing is like, sentence similarity and things like that, which is very limited. So we did a human evaluation with 19 participants, 25 to 53 age group. They had different backgrounds. They also had different video game experiences. And we asked them to generate a game, and then they evaluated it on a like 5 scale, 5 things. Like ease of use, creativity, alignment to what instruction was provided, the believability of the characters, and the overall satisfaction. Overall, it was positive, but there were some interesting aspects. Like for example, creativity had a huge distribution. It is basically because like the characters themselves, since it was focused on the overall narrative arc, the character themselves did not have too much personality. Like some of the research that we heard like in the last few days might be interesting to kind of inject into this. They were pretty bland, and so that kind of reduced the creativity in terms of like what was happening. And of course, LLMs tries to do the highest probable path, so you're not going to be surprised as much in some of these generations. The alignment also had some variance also, because like sometimes you give a very generic prompt like visits the island to learn about his grandma's past, so that the person who giving the prompt has like a very different vision of what the story should be versus what gets generated, and that might be some of the reasons why there was variance there. And of course, believability was low because some of the characters, the dialogues were a little repetitive, and overall satisfaction was positive. So overall it was positive, but not like perfect. So there are a lot of room for improvement. And in terms of like the experience manager, like I said, there was a mystery to be solved. So we looked at 2 kinds of we used 2 dimensions. One was known clues versus unknown clues, which means that the player has seen the clues versus the player hasn't seen the clues, and relevant versus irrelevant clues. There were 16 clues. Some of them were red herrings, so they were irrelevant to the mystery, solving the mystery, and some of them were relevant. So these were the 2 dimensions we looked at. So when you look at hints, you want them to be like unknown clues and relevant, unknown and relevant, versus known and like irrelevant. So that's what we noticed in the distributions. And in terms of summary, we want it to be known and relevant, because we want the summarizer to talk about what the player has actually seen in the game. So that was what we did with the distribution. You actually see that the most of the summary was mostly known and relevant, was closer to known and relevant clues. Finally, again, we did the same. 19 people played the engage experience manager aspect as well. They rated it on these 4 scales. Of course, they found it engaging, coherent, but believability was variant, because it might just be that the game was too simplistic with just 3 characters, and like somebody actually telling you all the clues instead of you going and figuring that out, which might have impacted the believability score. Overall, they were very satisfied with this. So to summarize, the NarrativeGenie can simplify generation of the games. You can it still allows for player exploration, even though it's the narrative kind of there's scaffolding in place to kind of direct you in the right direction. And of course, we evaluated that with automated and human evaluations. In terms of adaptive generation, it does generate coherent interventions, but it is not, even though it's adaptive, it's not taking care of the player skill level and some of the other things. So it kind of, when it gives hints, it kind of gives a very simple hint. It doesn't kind of understand to give nuanced hints and things like that. So those kind of aspects were something that we want to work towards. And in terms of the overall framework itself, there are some limitations, and of course that leads to possibility of future work. The narrative quality itself could be improved. That is something that we need to work with, find out how to make some stuff interesting, the conversations more interesting and things like that. We do not have any guardrails for ethical or sensitive issues. We're just using LLMs out of the box, which is something that we need to work towards, because as we are targeting an audience of children and teachers in classrooms, that's one of the goals of this this framework. So we need to make build something around some guardrails around what's generated. And finally, of course, we want right now it's fire and forget. You just give like a 50-word summary and everything gets built. We want to we are building right now ways in which you can intervene at different stages and kind of edit and make the generation more better. And finally, and thanks to NSF for the support.